A deployment named Apache Server is running, and the exam wants it auto-scaled on CPU, a 50% target between 1 and 4 pods, and a 30-second scale-down stabilization window. Let's build the horizontal pod autoscaler and see why the obvious one-line command can't finish it. Here is the task. In the Autoscale namespace, create a horizontal pod autoscaler named Apache Server that targets the existing Apache Server deployment. Set the CPU target to 50% average utilization per pod. Allow a minimum of 1 pod and a maximum of 4, and set the scale-down stabilization window to 30 seconds. 2 things have to be true before an HPA can do anything. The pod needs a CPU request, because a 50% target is a percentage of that request. With no request, the HPA can't compute utilization. And metrics server has to be running, because that's where the HPA reads live CPU. Given both, the HPA watches CPU and adjusts replicas between your min and max. The scale-down stabilization window tells it how long to wait on falling load before removing pods. Start by reading what's there. The Apache Server deployment and its service are running in the Autoscale namespace. Open the deployment manifest and look at the container's resources. Crucially, the pod template sets a CPU request of 200 millicores. That request is what makes a percentage target meaningful. 50% of 200 millicores is 100 millicores per pod. Confirm the HPA will have data to read. kubectl top pods returns live CPU and memory from metrics server. If this command errored or showed nothing, the HPA would sit at targets unknown and never scale. So verifying metrics first saves you a confusing debug later. Now the fast path. kubectl autoscale. Pass the target, min, and max, and it builds an HPA in one line. On a current cluster, the dry run even emits API version autoscaling/v2, with the CPU target already inside a metrics array, so it looks like you're done. But scan the whole object, there is no behavior section anywhere. The scale-down stabilization window has no flag on this command, so the imperative path gets you 3 of the 4 requirements and stops. Before you apply anything, know that there is no kubectl create that emits a behavior block. So part of this is copy-paste from the official docs, which you are allowed to use in the exam. 2 pages on kubernetes.io cover it. Search HPA and open the horizontal pod autoscaler walkthrough. It shows the autoscaling v2 object with the metrics array, the shape for the CPU target. Then open the horizontal pod autoscaling concept page and find the section called Configurable Scaling Behavior, with its stabilization window example. Lift the scale-down blocks straight from there. In practice, generate the skeleton with kubectl autoscale dry run, paste the behavior block from that section, and set the window to 30. So finish it in YAML. Take the skeleton and add the one piece the command can't give you, a behavior block where scale-down stabilizationWindowSeconds is 30. Watch the trap the walkthrough hit. In autoscaling/v2, the CPU target belongs inside the metrics array as average utilization. So don't paste an old v1 targetCPUUtilizationPercentage field next to behavior, or the AP server rejects it as an unknown field. Apply it, then list the HPA. It shows the target against 50% with min 1 and max 4. Verify every field, because each is a separate mark. Describe confirms the reference to the deployment, the 50% CPU target, and the 1 to 4 range. Then read the stabilization window straight from the spec. 30 seconds, exactly as asked. With the CPU target reading a real percentage, the autoscaler is live and complete. A few traps to remember. kubectl autoscale is fine for min, max, and the CPU target, but it has no flag for a stabilization window. So when behavior is required, you finish the HPA in YAML. In autoscaling v2, the CPU target lives inside the metrics array, not as target CPU utilization percentage. Mixing the two is the unknown field error. The pod needs a CPU request, or the percentage target is meaningless. And if targets shows unknown, suspect metrics server before the HPA itself. To recap, a CPU request and metrics server are the prerequisites. kubectl autoscale gets you most of the way, and the scaleDown stabilization window forces an autoscaling/v2 manifest with the target in metrics and behavior alongside. Verify each field after applying. Subscribe, and the full write-up is on dev.to.